There are mainly two types of people are involving in designing and programming. The set of people who design the computer are called architect, and the other people who use this computer to do some task like programming, they are called as programmers. And there are different types of computer. One is called general purpose computer, which is we use every day like laptop, desktop, which can do almost everything. And the other type of computer is specific to some task like washing machine, which we can set timer, and after that timer that washing machine will stop. Those are the tasks washing machine can do. And this type of computer is called as embedded system. When you look at the embedded system or the computer, the core of it is the microprocessor, or the processing unit which is present inside the computer. And the main difference between various types of computer is, depending on what is the computer supposed to do, designer will choose the hardware circuit and then they will try to connect them. For example, if you look at the general purpose computer, the main important thing it will contain, we are going to use a stored memory concept. That means we are going to put a program into the memory. Let's say this is the memory, and we are going to put the program into that memory, and we are going to take that program from that memory. After taking the program and the data from the memory, we are going to execute that program, and after executing we are going to put back that program into the memory. Therefore the most important part is the memory. But we know the memory is comparatively slow from the register. That is why we have registers. And how many registers will we have, that depend on the cost of the system. If the cost of the system is very high, then we can use many registers. As the register is so costly, if there is so many register in our system, then the program will be small and we can process the program very fast. But if the register is so small, when there is less number of register, then the each instruction side will be big, so the program size also will be become very big. And there will be one unit which is called arithmetic logic unit in the system also, which will perform the arithmetic logical operation. Now our main purpose is we have to move the data from memory to register, and then from register to a arithmetic logic unit. And after that, after performing that logical or arithmetic operation, we have to put back the data into the register, and from the register into the memory. To do those operation, we need control signal to do this. For example, if we have like write something on this register and read something, then we have to give the control signal, write control signal to this register and read control signal to this register, both at the same time, to do this operation. Like write here and then from read from this here to here, R1 to R2, we have to give the control signal both of those register at the same time. And this control signal will given by the control unit to each of the memory. All these types of memory will be connected by the designer, means computer architect. That means who made the computer, who will make the computer will connect all those type of memory. I mean the main memory register or ALU. The designer will connect all these depending on how the programmers wants to perform. So the designer will connect all these depending on how the programmer wants to perform. Before designing the computer, designer have to set first instruction set or machine instruction. Yeah. This instruction set or machine instruction designer have to set first those. Using instruction set, programmer and designer will interact with each other. Programmer will send to the instruction set or machine instruction what is needed to in order to write the program, and based on the instruction set information, designer will choose the hardware and connect them. So programmer will send to the instruction set or machine instruction what is needed to write the program, and designer will see them, and designer will see the instruction set and choose the hardware and connect them. So the place at which the programmer and designer will interact with each other is the instruction set. That is why we have to discuss the instruction set first. So based on the what is your instruction set, we will see are the components required, and we will connect them based on that. Now we will first see the instruction and the addressing mode, and then we will discuss about the instruction set later. Now let's see how the instructions look like. Instruction is nothing but a sequence of bit. We write a program in terms of instructions, and that those instructions will be present inside the memory. Like this is, let's say this is the memory, and the instruction will be present inside the memory, and there will be many instructions present inside the memory. And let's say the instruction start from memory address 200, and we will take each instruction from memory at one at a time, and we will put this into the special register called instruction register. So this is the instruction register. We will take each instruction from memory and we will put this into the instruction register, and every computer will have this special register called instruction register. After seeing this instruction, CPU should understand uh, the instruction. That is why to generate the control and jamming signal. That is why CPU this instruction will be divided into parts, and those parts mainly there will be three parts, and one part is called mode, and other part is this part is called opcode, and this part is called operands. And the different type of opcode that is possible is addition, subtraction, multiplication, increment, and many more there is. So this opcode is used to tell what is the operation this instruction is going to do, like addition, subtraction, increment, multiplication, those operation which is going to do this instruction. This is tell by the opcode, and these operand fields will tell where the actual data is present, and whenever information is present in the operand, how to interpret this information is being given by this mode. This mode will tell how to interpret this information. Now first we are going to discuss about types of mode, which will tell how to work on the operands field.